All right. All right. So welcome to Require Alex edition number ? I'm not sure if we ever counted, but this is the 26th of February edition. So yeah, first of all, thank you Riskified for sponsoring this edition, and FinTech House for letting us be here as well, I suppose. And I know that we don't organize these very often, but if you ever want to collaborate, submit topics for talks, please do reach out, because we're always open to partnering, collaborating on future talks. So yeah, feel free to hit us up. But in any way, my name is Afonso. I work at YLD, but again, Require Alex belongs to the community, not just us, but we kind of try to be keeping the legacy alive, because I'm not sure how old it is, but I think it's probably around, I'm going to give my estimate of 9 years, maybe more. Right. So, yeah. There is only one emergency exit, so if anything happens, please leave orderly and leave your bags behind. We will try to get maximum profit of them on OLX, so yeah, please do remember to have insurance. If you don't, sorry, now it's too late. So yeah, without further ado, let's go over the agenda today. So we've already opened the doors. We're here. And so next up, we'll go for intros, which I'm doing. And next up, I'll see if we have some introductions as well from the organizer, so YLD and Riskified. And then we'll have the Achieving Sub-Second Real-Time Analysis by Near the Nets from Riskified. We'll have a talk around monorepos by Tiago, and we'll have a talk about MCP servers, which you'll know more about at the end, I'm sure. So thank you, Pedro, for that one. And finally, we'll have some networking, and I'm sure that we'll have some time for Q&As after each talk. So yeah, strap in, and let's get ready to take off. And Maria, would you like to come up to the stage to... Right. Thank you.
Also testing. Yes, it's working. Yes, it works. Hi, everyone. Thank you, Afonso. And I also want to thank you not just to FinTech House, but also to Riskified as well. I'm Maria Luís. I'm part of the talent team from YLD, and as Afonso said, so Require Alex is a community event that's been going on for a while now, and YLD is very proud to own and organize the event, and it's great to see all of you here. It means the community is alive, and hopefully we'll do more of these throughout the year. I also want to use part of my 5 minutes, and now that I have your attention, to brief you a bit on what YLD does. So we help clients build and improve their products and their services. And we're able to do this for over 10 years now, thanks to engineers like Afonso, Tiago, product designers, and data engineers as well. We've been doing this from our offices here in Portugal and in the UK. And again, it's the only reason we've been doing this for so long. It's because we have an amazing tech team. I won't take too much of your time, but if you want to know more, we have a couple of our engineers here tonight, so you can walk around, ask them a bit more about what YLD does. We also have a lot of business cases on our website as well. So as you can see over there. So yeah, that's it. Thank you all for having us, and I hope you'll learn a lot and network, and it will be fun. Thank you.
Thank you, Maria. Right. And next up, I'd like to call Aline, where she's. Okay, there she is. And it's on.
On. Thank you. Also, Shai is here with us, so I'll let you introduce.
Yeah, I couldn't help it. So I'm just visiting Lisbon for a week, visiting our new office here. And my name is Shai, and I run engineering for Riskified. And we wanted to tell you a little bit about what Riskified is doing. Riskified is in e-commerce. Actually, I saw this sign here, and I said that we can use it. It's all about creating a frictionless and holistic financial or e-commerce experience right where you need it. And I think that describes very well what Riskified is doing. What we're doing is we're protecting e-commerce organizations around the world from fraud, and hopefully making the world a little bit better, because we allow people to shop online in a frictionless way, while we protect the organization, the e-commerce organization, from fraud, and not invest too much money in it and spend a lot on chargebacks and stuff like that. So this is what Riskified is doing. We exist like a bit more than like 12 years now. And a year and a half ago, we opened the Lisbon office because we wanted to access more talent and allow better business continuity. Wait.
Oh, sorry.
Yeah, I'll move there. So Riskified is like, we are about 750 employees. We, as you can see the numbers, we're dealing with a lot of the business around the world, globally. Mainly work with enterprise organizations, a lot of customers like Macy's, Booking.com, and others. And I think that we'll move to the new office, which we opened a year and a half ago. And Aline is running this office. She relocated from the Tel Aviv office, and I'll let her talk about it for a while.
So, hi, I'm Aline. I moved here almost a year ago now. As you can see, we opened the Lisbon office, and we're quite small for now, but we're getting bigger, and it's really, really fun. I work personally in Riskified for 11 years, so not very common in this industry, I know, but really, really nice in its maybe. But maybe it shows how much I like working here and how much it's interesting and evolving and challenging over the years. You can see here a little bit about what we work with and how much fun we have here in sunny Lisbon. I'm really, really thankful for this community hosting us to work together with Require Lex and and YLD. And hosted here in the FinTech House. Everything is like very much connected. Just today we announced at the office that we are moving to a bigger space, so it's a lot of exciting news for me in one day, so sorry for that. And really happy to see that we'll have very interesting conversations here. So let's start.
Thank you.
Thank you. So we'll now go into our first talk. So Nir, oh, there you are. You can. Thank you.
Hey. Okay. So, thanks everyone for coming. Today I'm excited to talk about how we achieved a sub-second real-time analysis, walking through a performance optimization we made, And I'll show you how we did what every developer dream of, taking a legacy code system and rewrite it from scratch. It's not a joke. But before we dive into our journey, let me introduce myself. So, my name is Nir. I'm working as a software engineer at Riskified for around 4 years. In a minute, I will explain why I say around. I moved to Lisbon a year ago, and I really like here. The people, the environment, mostly the good wine. And I really like adventures and traveling so much that in 2022, I decided to take some time off that turns into 2 years of traveling around the world with my wife. 5 continents, great journey. But we will not talk about this today because that's completely different journey that didn't last less than 1 second. Yeah, so that's me. What will we talk about today? I will give you a quick introduction to Riskified, who we are and what we do. We will walk through Riskified journey over the year from the very first beginning, how we start our system as a monolith and eventually built our new microservice architecture to meet our performance need. And during this journey, we'll see how the business requirement that changed along the way shaped our architecture compared to the legacy architecture, and we see also the challenges that we face along the way and how we overcame them. And finally, we will break down how we achieve the sub-second latency. And of course, we will wrap up with some time at the end for a question. So Riskified, what is Riskified and what we do? So Riskified is a leading e-commerce fraud prevention and chargeback protection company. We provide machine learning-based solution designed to help online retailers to enhance their fraud detection, improve customer experience, and maximize revenues. And today our focus will be on our main product that's called Chargeback Guarantee, that serves actually as a foundation to many of our other products in Riskified. So what is Chargeback Guarantee? Chargeback Guarantee is our core product that provides comprehensive protections against fraudulent chargebacks for e-commerce merchant. With this service, Riskified takes the financial liability on any fraudulent chargebacks, guaranteeing all the transaction and proof within our system. So how does it work? So imagine you're checking your monthly bank statement and suddenly you noticed, this is your monthly bank statement, and suddenly you noticed a payment you didn't make, like this. And what will you do? You will probably call to your bank and ask to dispute the charge and request a refund. The bank will ask from you for some details, will investigate the case, and will return the money to you. But what happens behind the scene that you might not know? So when a customer contacts the bank, then the bank reach out the merchant where the transaction was made and ask them to return the money. And this is what makes the merchant's responsibility to handle any potential fraud in their system, even though they simply want to focus on selling their products. And that's exactly where Riskified steps in. So at that point, a merchant that works with Riskified, passing along the dispute information, and we take the full responsibility and reimburse the merchant so he doesn't suffer from any financial loss. And this allows the merchant to operate with confidence and to focus on growing their business while we take the risk by ourselves. So here we can see an high-level flow of our analysis within our Chargeback Guarantee product, from the moment merchant transaction enters to our system to the final decision. So typically, the merchant sends us some basic information such as email, name, address, and then we enhance this basic information in step we call enrichment by pulling additional data from both internal and external data sources. These sources provide us some crucial data that can affect the final decision, such as customer history, risk signals, and some more data. We will talk about this data source a bit more in detail in the next slides. In the next step, we calculate feature. Unlike what we typically mean when we're talking about developed features in product, here features refers to the input fed into our machine learning models. But what are exactly features? Features are pieces of data that calculated based on the data from the previous stages, such as the enrichment and the merchant transaction. And what's important to understand that these features are the input to the next step in the process. So in the next process, the decision, the calculated features got as an input to the machine learning models, and it outputs a decision based on its current input and its training data, and the decision can be either prove that we say this transaction is safe and we're guaranteeing this transaction, or even decline that we said, okay, there is a risk, this transaction should be declined. So to this process we call analysis. So let's take a look at the journey we went over the year and see how this chargeback product has some changes along the way. So in 2013, Riskified started developing its chargeback guarantee product within the monolith. Initially, the architecture worked fine, but as we added more features and more capabilities, the system became increasingly complex. So in 2020 and the beginning of 2021, we started to extract some important components, such as the analysis itself and the feature calculation, to different dedicated services, which improved the performance and the scalability and the flexibility of the system, and it helped for that time. But then, in 2021, December 2021, a new business requirement emerged, demanding sub-second real-time analysis. So let's take a look at those requirements. So the first key requirement was to have fast analysis, sub-second real-time analysis. In e-commerce, speed is important, and for some industries, it's even critical. Think about it. You're about to purchase a flight ticket, and you have to wait a long time. You may reconsider the website or your purchase, and you may leave the website before completing it. The second key requirement was to expanding our reach to as many industries as possible, such as flight tickets and food delivery, such as other industries that needed a really, really fast analysis. And by supporting these different industries, we're expanding our reach to more customers and growing in the e-commerce market. And the third, that you might think that, okay, it's not a new requirement, but having said that we need a fast analysis system that knows to process and process and handle large transaction volumes, our system should be reliability and scalability during this processing. So at that time, we look at our architecture and we try to understand if we can meet those requirements with what we have back then. So at that time we call it our architecture, now we call it our legacy architecture. And let's see what the challenges we face with. So as I said, the monolith was written in Ruby based on some old versions that didn't support concurrency. It also made it very difficult to scale, that made our system very slow. Having said that, initially we had a very high latency, and although we managed to improve it over time, we couldn't reduce to the desired target, and it made it even difficult during the time and the complexity of our system. And one more thing, that we had a limited end-to-end visibility in our system. We couldn't monitor our analysis from first to start, which made it hard to identify latency issues or any other problems in our system. And our system was relied heavily on the database because of many time-consuming back and forth queries to our database in order to fetch some related data to this transaction and to store the transaction state itself, which make it very slow, further increasing latency. So the challenges that we faced, together with our business requirements, highlighted us the need for a change. So we understand that there is a need to break free from the monolith. So in January 2022, we started to work on our new architecture, new microservice architecture, and we tried to work with some core features to go launch as fast as we can. And in July 2022, we went live with our first merchant. That was a significant milestone for Riskified, a system that handles transactions in less than 1 second. And we will focus more about this part and how we achieve it in the next slide. But before that, in 2022, between 2022 until today, we added more and more capabilities to match our legacy architecture and to migrate more merchants to our system. So, how did we achieve the sub-second latency for our real-time analysis? Okay, so, just a second. So, before we broke down the monolith, the merchant transaction communicated directly with Riskified API. So our first step was to extract the analysis component to a dedicated service within our new microservice architecture, like you can see. And this gave us several key advantages. It helped us to define efficient and clear API separated from the merchant transaction API, which had been very challenging within the monolith. We gained from it the ability to scale our analysis independently without affecting other components in the system, and the simplified code in the new service made it very easy to maintain and reduce the complexity of our code base. It provided us the flexibility to deploy any updates independently as well, would reduce the deployment risk and minimize downtime. And also we were able to allocate resources more effectively, reduce the insufficiencies, and improve the performance. So we can see that only from separate this service, this component, this main flow to another service, we improved the performance and we gained a lot of benefits. And another crucial part over creating the new services was the adoption of gRPC communication between our services, which improved the performance and lowered the latency by using HTTP2 over the hood to handle multiple requests over a single connection. And also, it provides us strongly typed contracts, ensures efficient, clear, and error-free data exchange, and with its cross-language support, it helps our service to communicate with each other, even though they're implemented in different languages. In the next step, we focused on maximizing parallelism to reduce the processing time and to improve the scalability without affecting other components in the system and without affecting the system stability. So how we did it? So we processed the data sources, those that I mentioned before from the enrichment part, we processed them in parallel rather than sequentially, which made the analysis much faster and handles large transactions volume much more efficiency. And by structuring the parallelism of the data source in levels, we ensure the correctness because we did it based on their interdependencies. So we ensure the correctness, the correctness of the code, and we maximize it by the parallelism and improve the performance and lower the latency. Over that, we implemented timeout budgeting mechanism at each stage, ensuring none of the stages delays the entire process. So if a stage exceeds its timeout, we proceed in a process and handling the missing data later. For missing features from the feature calculation step, we set default values and predictive model to preventing the whole process from failures or any delay on the process going. And a pivotal part of our journey to reach the real-time sub-second analysis was the transitioning of our analysis to a fully stateless architecture. So as I mentioned earlier, one of our challenges, maybe the biggest one, was the heavy reliance of our analysis on the database because of many time-consuming back and forth queries to fetch some related data, to store the transaction state, and it was really hard to identify some issues using what we had this time. So in the new architecture, in the new service, we fetch instead of fetching the data from the database, you got the data as an input, and we store the transaction state after the analysis rather than during it. This made the processing of large transaction volumes scalable, reliable, while reducing memory usage and storage needs. And that was a really game changer for us at that time because this separation lowered a lot the latency and improved many aspects of scalability as well in our system. And a last key aspect of our journey was the implementation of a robust monitoring system. So it's not that we didn't have at all monitoring system in our legacy architecture, but it was limited and it was really hard to identify issues and to optimize the performance. So in the new architecture, we used Grafana and Prometheus and some other tools to enhance our monitoring system, and we added a detailed metrics to any stage in our system, including end-to-end, and for every step in the analysis flow, including the enrichment, the feature calculation, decision-making. And this allows us to set a real-time alert, allowing us to investigate latency issues. And by continually monitoring these metrics, we can quickly resolve problems and to ensure optimal performance and the reliability on our system, of our system. So, as someone wise once said, new is always better. Yeah, maybe not always, but for our case. So if we take a look on the decision we made on our journey, we can see that they shape our architecture to meet our performance need and to meet our requirements, and we gain from it a lot of other benefits. So, in terms of stack, we could choose the most suitable and cutting-edge technologies to our performance needs. So we use Scala and Node to improve the performance and scalability and the concurrency of our system. The microservice that we use versus the monolith that help us to separate the concern of every component and also improve the performance. And we use Grafana and Prometheus, like I mentioned, to enhance our monitoring system. And in terms of features, so now our system is much more modular. We can use it for offline processing and for research usage. We're using Spark and Databricks. Our system now is much more resilient with counters that have metrics for every part, even small part. We can see even small functions in our system. And the separation from the database gave us the ability to maintain our system much easier. And the last and maybe the important one, from business perspective, we reach our P99 of 500 milliseconds, much less than 1 second, and customer satisfaction. Thank you. Question? Yeah.
I will perhaps ask. Thank you. Thank you very much. Thank you very much. I will perhaps ask a ridiculous question, but I will ask it. So, assuming I'm buying something, for example, by Amazon, okay? I choose what I want to buy. I have the basket of what I want to buy. And then Amazon is giving the possibility to choose how do you want to pay what you buy.
Yeah.
And then, for example, I choose the Visa card, and then I introduce all the data of my Visa card.
Yeah.
So, where is the risk? Because the bank will acknowledge the payment, and if I'm delivered, the payment is not done until the delivery is not done. So where is the risk? Is the risk from a false buyer for a false Visa card, or where is the risk?
Yeah, so there are many ways of frauds that can happen. One simple can be that someone steal your credit card and just use it. Some other can be that someone take your details on your of your credit card or the details of your account. There is many kind of frauds.
And you can detect that?
We can detect it.
Wow.
That's what we do.
And so your customer are banks?
Our customers are the merchants.
Are they?
The merchants. For your example, Amazon.
So you have as Amazon as customer and banks as customers.
So yeah.
Congratulations.
Thank you.
I do have one question as well.
Yeah.
You mentioned that you have multiple data sources.
Yeah.
And maybe this is getting into a lot of like the secret of the sauce, but like what are the data sources? Are they mostly internal? Do you have also external data sources?
Yeah, so as I mentioned, we have also both internal and external. I will not go into details of all of them because there are a lot, but some of them enhance the information, the transaction information by putting some customer history that you got and some data on the information on your name, on your phone, some details like that.
Okay, so you have a database full of data from everyone.
Yeah.
Right. If I request to delete my data.
We support it. Yeah, we are.
Any other questions? Yeah.
So Nir, you mentioned that you implemented time budgeting for different steps in enrichment phase. So if some phase hits the timeout, and we don't get this data, does it affect the analysis somehow?
So it did affect, it can affect, but we handle this missing data with some smart mechanism that know how to work without this data. Is that answer to your question? Yeah.
Do we have any mechanism for late arriving data to get it after we get initial decision?
For example?
So we didn't get this data initially,
Yeah.
and we get the decision, decline. But then we get this data.
You mean if we fail to fetch this data?
Yeah.
So we have a few processes, but usually we're getting the real-time data on this transaction. Yeah, we have some offline processing for that as well.
Okay.
Is your response always like false or true or false, or is it a score somewhere in between?
So the childbirth guarantee is work with decline or approve, and of course we have some fallbacks but also the return decline or approve. But we do have some score solution separated. Yeah.
And what happens if it's just in between? Is it going to be approved or is it going to be declined?
So it will always have like decision because we have a threshold, and order the score was behind the threshold. Or
so you can't have like someone, maybe it's a FOSR, maybe it's legit.
No way.
Never.
We do have some mechanisms without like 3DS or SMS.
Yeah.
Yeah.
So the less legit the people, the buyer is, then the more control you will add to the process.
Can you repeat it?
The less legit the score will be. I mean, the less the score will be,
Yeah.
the more control you will be able to add, or maybe the merchant. That's not your role, maybe. To add more control to the payout process.
What do you mean control?
Control is like, if you know that a buyer is a fraudster, you will add as much control you need to make sure it's not a fraudster anymore. But if you know this customer, you will just make it easy for him to have a frictionless.
We do have some mechanisms, like you said before about customer history, so we know a little bit.
So yeah,
Customer. We integrate it within the enrichment process, so it will affect your eventual score.
All right. And do you have like a back end for the merchant to be able to see the score?
Yeah.
Or good.
All right. Thank you.
Thank you very much.
Oh, wait. Another question? There. Sorry.
Okay. I can get it more and more. It's okay.
Thank you. Hello.
Yeah.
Hello. It's in front. So when I receive an email of a merchant, there are some photos of different products. Assuming I click only to see what is the product and the characteristics, it's possible that when I click, there is a message which is sent to the sender of the email, which say to the merchant, this man is interested by this product, he is looking at this product. So can you prevent this from sending such message?
Well, it's not our job.
Okay.
There is other product that do it, but not risky.
Okay. Thank you.
Yeah.
All right.
Okay. Thank you very much.
All right. Which one? Okay. Yeah. Tiago, would you like to come on stage? Sure.
Yeah. Well, hello everyone. Thank you very much for having me. First of all, I want to thank Require Alex for this opportunity. This is going to be my first talk ever, so be gentle with me and be patient. And also, I would like to thank YLD for this opportunity. I hope that you like it. This is a topic that I really like because since I joined my company, I since started working with the company, I had to start working with this kind of approach, with this subject, and this is something that is really interesting for me, and I hope it could be interesting for you as well. So let's get started. But before we go. Before we start with the subject, I would like to introduce a little bit. Who am I? What are my passions? So basically, my name is Tiago Duarte. I'm a software engineer for almost 4 years now. I joined YLD about 2 years ago as a front-end engineer, and I currently work for a fintech company. I'm a full stack developer, but oriented more towards the front-end side. And like I said, I like to explore the bridge between technology and human interaction. That's what makes me really passionate about front-end, and that's why I adore doing it. And in my spare time, when I'm not coding, when I'm not trying to solve problems regarding front-end and UI and all of that, I like to work with I like to take some photography, and also I'm a really big fan of motorsport, potentially Formula 1. Go Ferrari, go Lewis Hamilton. So let's get started with this subject, which is about monorepos. But before we get into that, I would like to speak a little bit more about the standards. So why do we need source code repositories? So why we need it? Because we need to have somewhere else to store our code in a place that we can not only use it or access it or change it wherever we are. That's the first thing. The second thing is because we want to foster a really collaborative environment, so that if we need to work on a repository where you want more people to work, you want them to work with you, we need to have a space where they can deploy their solutions into the repository. And you always want to have a place in which you can organize all of your code, right? So let's think about what exactly does a common repository might contain, and think about that. Because I'm more a front-end engineer, I will try to present, or the examples that I'm going to present to you are more towards front-end than back-end. But I think it's going to be really easy for you to understand for those who work more with back-end or not. So I think it's going to be easy for you to understand. So what do we have? Mainly, a common repository focus on one single project. Might contain source code, or it does contain source code, of course. It will have a dependency management system, some CI/CD work, and potentially some dependencies to external services or external libraries, okay? What exactly makes this kind of approach of single repositories, or as is academically known as polyrepos, the standard? So the first thing has to do with the fact that this kind of repositories provide you isolation, okay, and gives you the full control of whatever assets you have inside of the repository. It gives you control of what the languages you want to have inside of that repository. It gives you the control of what are the libraries and the number of applications you might have inside of it, and as well who can contribute to the code or not, okay? So let's think about one scenario, which is, let's say that you work or just start working with a team in a certain company, and you are responsible for working or developing 3 types of applications. Doesn't matter exactly what those applications are, but let's just say that the common structure of that applications are, you have a web app. That web app has some dependencies, some libraries in which it depends on. Might be data models, mocks, an UI shareable package, or even an authorization layer. And just if you want to add another layer into the scenario, let's say that team B is responsible for a certain one of the packages, let's say the authorization layer. And adding to that, that web application communicates with a server, and that server will communicate with some APIs and make connections to some databases. Let's say that. And also, think about, or put that in mind, that all of the packages, all of the modules that compose the structure are always are single repositories, okay? What exactly happens, let's say that you want to develop a feature in this scenario. And let's say that you have some order, some prioritization in terms of what models need to be developed first. So let's say that you need to develop the authorization layer. It doesn't matter what the features are, first of all, but let's say that you want to make a change on the authorization layer, you need to make a change on the UI shareable package, and then, of course, because you made that change into dependencies of the React application, you need to also update the versions of that or of those dependencies inside of the React app. So exactly what happens? So of course you need to, if you're starting from the beginning, you need to clone your repository. After that, you need to install the dependencies. After that, as soon as you have the local environment set up, you need to create a branch, a feature branch. And then for, let's say, the authorization layer, and the UI shareable package, you need to refactor the code. And after that, this one in particular is only for the React application. Once this is done, you need to update the package versions, of course. You need to create a PR. You need to merge that PR with main, and then you need to delete the branch. Of course, this is already automated in some platforms, but this is what you need to do, okay? What is the catch? The catch is you need to do this too much times. You need to do 3 times because you have three different repositories, okay? Another example. Let's say that you as a developer, you realize that you found some piece of code inside of one of the repositories, and you figure out that, well, this is something that can be shareable. And I would like to put this into a really fancy package that can be used by everyone inside of my team or other teams inside of the company. So what do you need to do? Well, create a new repository. You need to copy-paste the code that you found that can be isolated and put it inside of that repository. You need to think about the name and the version and think about versioning that package. You need to build CI/CD, of course, because you want to have automation and you want to do steps manually in order to make, to test the code that you want to isolate and to deploy and create the package and deploy it into some registry. Of course, you need to deploy the artifact. And then, after this, you need to, again, delete all the code that you isolated and replace the dependencies, or replace the imports and the references on all of the other projects that might take advantage of this isolation, okay? So I'm not sure if you already realize, but in order to do this, in order to do all of these tasks, you start to realize that this adds a bit of overhead. Why is that? Not because you need to focus, not only you need to focus on the main task, which is develop the feature or isolate the code, but also because you need to carry about all of the other things that are implied, DevOps or whatever. So basically, do project management kind of tasks and all of the DevOps operations that are attached to it. What are other issues that might be implied that are associated with poly repos? So you might have cumbersome code sharing. You have complex cross-repo changes, because if you need to do one change on one side of the repository, you might need to, and if you have dependencies between those repositories, you might need to also do the changes on other sides. You have PR madness, or as I like to call it, PRT. Joke doesn't work. And yeah, so basically you have PRs all over the place. You need to wait for those PRs to be approved. You can see that there's tons and tons of things that are really unnecessary. And just to finish this, you also have inconsistent tooling. Why is that? Because you might have, for example, you have a CI/CD pipeline that might be completely different, might have a different strategy to one repository to another. And you might, for example, inherit repositories from other teams that might have completely different philosophies, okay? Another problem that it's attached to poly repos, it's called dependency diamond. So I'm not sure if you guys are familiar with this phenomena, but this is really common with poly repos. And this is basically just to give you a quick summary of what this is. It's basically the problem where you have a certain project, let's say project A, that depends on another package or project called B and C, and those have a common third-party dependency. The main difference is one of the projects depends on one version of the package D, and the other one depends on the second version of the package D. What this might bring? Well, might bring version conflicts. And what happens with version conflicts? Well, you might have unexpected behaviors when you bundle all of that and you try to run your application. You might have incompatibility issues and all of that. And in some occasions, package managers, what they try to do is they try to do one of two things. Or they try to use multiple versions, and this, of course, can increase bundle size and potential inconsistencies. Or they can try to use one single version of the packages and pray and see if everything works. What would be really easy, or what would be really ideal to do is, what if we try to solve this just by, instead of having this problem, what if project B and project C depend on the same version of package D? And there comes monorepos, one repository to control them all. So if you think about it, about the scenario that I just presented to you, you can see that basically, if you think about the structure from the beginning, you have three applications with mostly this kind of structure. You might have a server, libraries, and all of that. And what monorepos try to propose is, what about having one repository that have all of these applications in one place? And that's basically what it does. So what you can see in terms of differences between one to the other is that instead of having your source code from the root level of the repository, you just have like a package folder in which that package folder might contain all of your modules, all of your applications, packages, whatever. App 1, App 3, all of that, okay? So what exactly is the definition of a monorepo? So monorepo or monolithic repository, it's basically a single repository that holds several projects. Those projects can be related or unrelated. Personally, I think that they should have some contextual relationship. So the packages that compose that monorepo, I believe it should have some context, because if you don't have any context, you might fall into the trap of, let's just dump whatever repositories or whatever packages I want to put here. And when that happens, you have what they describe here, or what I could find in terms of categorizations between types of monorepos. You have these two kinds of categories, which are project monorepos, which I believe are the monorepos just for common mortals like us, that is manageable, but just like with one developer or a small set of developers. And then you have what it's called monstrous monorepos, which basically everything that you want to put inside of your, let's say, company or project, let's say, you want to put it inside of all of that and in one single repository. And this is a common strategy that Google, Facebook, and Uber, use it. So, what exactly are the advantages of monorepos? So, to start, you have standardization. Why is that? Because if you think about it, now, because you have all of the packages, all of the projects inside one single repository, you can create generic pipeline work, or can create generic scripting or tools that can benefit and be used by all of the applications. So you don't need to worry about having different kinds of pipelines for all of the packages and all of the projects. It's one single thing for all of them. And this provides standardization, for example. Second thing is visibility. Why? Because now we have one single repository in which all of the applications live in, and so whatever devs need to work with this repository, they have everything inside of that repository, and they can visualize everything, and gives you the possibility to not have to have silos inside a project, inside a team, let's say. The other one has to do with synchronization. This is something I'm going to talk a little bit more in the next slide. And then you have centralization because, of course, you have all the packages in one single repository. What other benefits might bring to you? Modularity. Why? Because you are able to have all of the applications you have there can be identified as single modules, in the sense that, and I try to put this on the chart, on this representation here. If you look into the way that the applications are structured, you have everything built in such a way that if you need to, let's say, remove one module and bring that into another team, hand over that into another team, that is possible, and it's just as simple as grabbing that application, putting that into a repository, and that's it. You don't need to worry that much about other stuff. What else? Simplifies the dependency graph, because now if you have common dependencies between all of the apps, all of the applications, you don't need to have repetition, you don't have to have duplication. You can just basically have one version of that dependency that can be used across all of the others. So, and this will reduce also the bundle. What else? You might have better organization, and then you have better coordination within the teams that might work with this structure. Speaking about synchronization, why is that possible? Well, this is possible because one development strategy that is called trunk-based model. I'm not sure if you guys are aware of it and how that works, but basically it is different from other kinds of strategies because you tend to force all of the devs to work or to commit all of their changes into the main or trunk branch. And also, it's really useful, or try to imply a policy of having short-lived branches. So this helps you to not have to have like really long feature branches that stay for so many times, for so long, for such amount of time into the development process, which might cause merge conflicts, for example. And in order for you to have that, the benefits of having these short-lived branches forces the devs to make comments quite frequently. By having that, it helps the continuous integration of a project, because forces the unit tests to be the testing associated with the project to be continuously being executed. Also, it prevents or allows for you to find bugs more easily, so that you don't need to deploy, or you don't fall into the trap or accidentally deploy bugs into production. So it's safer. And also, because of that, it enhances stability and the quality of your code. So, if you think about what I've just showed to you, let's try to recap the scenarios that I showed you before about developing a feature and sharing reusable code. So, a reusable code. So, what we need to do to develop a feature. So, right now, we just need to do this. It's more or less the same. Apart from, you just need to do it once. You need to clone a repository, install the dependencies, create a branch. All of the work that it's implied with the task, which is update the dependencies and refactor the code, can be done in the same place. You create a PR, you merge into main, and you delete the branch. That's it. And what about sharing reusable code? Well, that easy. So what you need to do is basically create a new folder inside of your repository, move whatever code you want to isolate it into that place, and potentially the IDE that you're using will resolve all the dependencies, all the imports for you, and that's basically it. Let me just check what's happening here. Okay, it's available. Cool. I'm not going to do anything. Any questions? Any issues so far? Can I continue? Nice. So let's say that I was able to sell this approach to you quite well, and then you think, well, I want to start using monorepos right now. How can I do this? Well, for me, I believe there are three main things that you need to be worried about, and you need to understand how those things work. First of all, has to do with package management. How does this is done? This is done inside of a monorepo. Second thing has to do with task running processes, and the third one has to do with scaling. Let's start with the package management. So let's say that you're now in a place where you want to put all of your applications of your project inside of this repository. Well, it would be ideal if we could figure out or resolve the dependencies in such a way that not only once I try to install those dependencies in order for me to start working with the project, I have to have duplications of all of the dependencies. And also, because we need to be aware that in spite of having the projects in one single repository, we always want to make sure that the usage of those dependencies in the projects that incorporate that monorepo are made in such a way that it's not basically just referencing local references of those packages inside of the repository. So let's say that you want to take advantage, like what I say here, so not have duplicated dependencies over the code base, but also treat the dependencies as if they were being pointed to a version from the registry, let's say. So one way of doing that, and this is something that package managers already provide to you, is what it's called the workspaces protocol. So this was something that was introduced with Yarn at the first place, but now common package managers like PNPM or NPM already provide this. And basically what they try to do is they find the dependencies and they fetch the dependencies once, and then they use symbolic linking for you so that you don't need to install those dependencies twice inside of the repository. Basically, that's how things are done. And this is the way that the package management systems try to handle the dependencies inside of a project, let's say. What about task running processes? So now, again, you have projects or many projects inside of this repository, but you face a situation where you don't want to have for every single build, every single install, every single lint type check test command that you want to do. You don't want to have to do this for every single project that you need to work with. Well, I would like to take the advantage of managing command executions and possibly have a way to make some recognition of the projects that I have inside of the monorepo in order to find a better way to orchestrate those tasks. So Lerna, not sure if you guys know what Lerna is, but basically Lerna was the first tool that initially introduced all of these features. But the problem is it's really hard to, or it's really cumbersome to try to apply those configurations in that platform, in that tool. Nowadays, you have really interesting tools that provide you all of the features, or basically some of really handy features that I'm going to present to you next. So you have all of these tools. So the first one is NX, the other one is TurboRepo, Bazel, Lag, and Moon. So I'm not going to make a comparison between all of them. What I'm just going to do is speak about what all have in common, but I just thought it could be easy for you to just have some references to the tools. So if you're interested about using those tools, you can easily just search for them, and I'm sure that he will give you some proper documentation to how to start using those tools. So what those tools have in common that are really handy for you to work inside of a monorepo. So first of all, you have incremental adoption. So you don't need to take full advantage of the tools if you're not ready to use them. So you can incrementally adopt the tools. It provides you task coordination, which is really handy, and something I didn't told you before. I'm using as a demo. I'm using TurboRepo just for you to have some visual cue or visual representation of what I'm trying to explain here. But provides you task coordination, so gives you an opportunity to run the commands in such a way that if you have dependencies within packages, let's say they have a React application and that React application has a dependency with an UI package, of course that if you want to run the React application, you want to make sure that the package from the UI shareable component or the UI shareable package, it's built first. So the task coordination is a feature that is provided by those tools. So it allows you to do that. And as an example, what I tried to show you here is basically an example where you have many modules, and as you can see, all of those modules are being executed at the same time, and some of them already finished, for example. The other thing is local computation caching. So it allows you to not only run things in parallel, but if you want to run them twice, or more than once, let's say, you already have caching. So you don't need to, or the time that will take for things to be executed will be really, really short. So on this example, what I'm showing you is I'm running a build command once. As you can see, there are 6 tasks that are executed. Nothing is cached. It takes you around 9 seconds to execute. But once you do it again, because everything is cached and no changes were made, it will identify that. And of course, the operation will take like 207 milliseconds, from seconds to milliseconds, which is really amazing. The other thing is basically the same thing, but instead of being pointed to a local environment, is more towards a distributed environment. So let's say that you want to run your CI/CD pipeline and you want to run it on a monorepo. You can have, for example, you can build the packages, cache them, and they can be available to CI agents, so that once they need to use whatever artifacts, they don't need to build it anymore because everything is already cached. Another thing really handy has to do with workspace analysis. So basically, those kinds of tools are really handy if to make like a comprehensive analysis of what you have inside of the repository, figure out what the dependencies are, and give you a really nice graph about what are the dependencies. So this gives you more visibility. And another thing that I would like to show to you, and this comes a little bit associated with what if inside of this monorepo, this is not just one team using it, but you have like more teams using it, and you have more, the size of this monorepo is a little bit bigger. Because you have this, let's say like, you don't have rules inside of a monorepo in the sense that if you want to easily use one dependency or one package into another, you can easily, in theory, you can easily just make an import. However, in some places, in order for you to incorporate some rules, some tools like NX, for example, offer you this modular boundary rules, which is basically some configuration that allows you to say, well, for this particular package, I don't want this package to be imported by package A or package C or whatever, which is also really interesting. And that's basically it in terms of tooling. And now comes the problem of scaling. So this is really interesting. The monorepo approach is really interesting if you're thinking, or if you're working with a project that might have like 1, 2, 3, 10 applications, but let's say, or packages. But let's say that your monorepo scales. Instead of having like 10 projects, you have like 100 projects. Well, you can, or in terms of development feedback, development workflow, you will have or basically your development workflow will be affected by 3 main things. First of all, it has to do with space, because it will not be that easy to just clone a repository that instead of having like 5 gigs might have like 50 gigs or 500 gigs, for example. Another one might have to do with time, because not only you can't, or it's impossible or almost impossible for you to download that amount of a repository, but also it will take too much time. But also it will affect your cognitive effort, because in order for you to try to search on that on such a big repository is really hard to do. And even the common tools that offer you search capabilities might have some difficulties in order to give you the results you need. And this is a really interesting metric that I thought would be interesting to show you guys, that has to do with what are the metrics that seem to start. When you have this kind of metrics, this is where monorepos, the scaling of a monorepo starts to become an issue. So for example, if you have inside of a monorepo, if you have 10 to 100 developers writing code full-time inside of that repository, if you have 10 to 100 projects in progress at the same time, if you have 1K to 10K version dependencies, or if you have 1 million to 10 million lines of code, that's when things start to become difficult for you to develop in your local environment, let's say. And also at the same time, because you start to have your project starts to scale. When that happens, usually at the same time, it's because your company, your project, whatever, also starts to scale and start to become big. And when that happens, sometimes you have investment or you have capabilities to basically invest in your own tooling. So you can invest in tooling to solve problems like file system, for example. You can, and basically, let me just check. Yeah, custom tooling to help them mitigate the side effects. The first thing has to do with virtual file systems, and then another possible solution that those companies might try to solve or might try to tackle is try to provide tools like search as a service tools, which is basically more complex tools that offer you capabilities to search on those kinds of big repositories. And one clear example of that is Google. So Google is, if you don't know, Google is one of the companies that has the most famous monorepo in the world. All of its code base, it sits inside of one single repository that is used by 20,000 developers, and they have invested really hard in tooling to help them mitigate the problem of scaling. Well, what are the concerns about monorepos? So first of all, it has to do with complexity, because of course you might have all of these projects inside of one repository, but this adds complexity into the code. You might have tooling overhead, because you need to think about creating tools specific to solve problems for a particular monorepo, and that brings overhead, of course. Also, you have over-engineering, trying to find solutions to solve the basic structure, let's say the real problem or the real core of what this problem, what this approach is, which is having many packages inside of one repository, and then you might have build and test plots and deploy problems. So if I tried, or if I was able to explain you this well, or well enough, you start to realize that the technical arguments, there are no technical arguments to decide between what if you want to use a polyrepo approach or if you want to use a monorepo approach. And companies have suffered really hard in how to find arguments to determine whether I should use one approach or the other. And because they don't have technical arguments to figure that out, they need to jump and start thinking about other kinds of problems. And that's when they turn towards the philosophy of the company and the culture of the company. So basically, they figured out that in order for you to determine whether if you want to go for a monorepo or a polyrepo, you need to start thinking about what is the culture of the company, how the company works, how the developers work inside of that company, inside of those teams. If they want to have like a more collaborative environment, or if they have silos within the company, or if they want to have, for example, projects or companies that focus on one single project, let's say. And I believe that the best example that I can give you is between those two companies, Google and Amazon. So two completely different companies of the tech industry. One follows the monorepo approach and the other one follows the polyrepo approach. But both have completely different cultures. For example, Google has a culture where there's, like I told you, has open collaboration, shared ownership, visibility of the code. So basically everyone can try to access or search for whatever they want inside of that big monorepo. But as opposed to Amazon tried to emphasize more on the autonomy, having rules like, for example, the 2Ps rule, which is having teams or small teams that are responsible for one single microservice or repository. And because of that, and also because of what the teams or what the companies try to have, you can see that Google offers or tries to reach a more holistic team cognition, which is basically trying to have all of the, let's say, experience and all of the expertise of the team members integrated. So let's say that I work for a team inside of Google that everyone has like different backgrounds, everyone has different perspectives of and expertise inside of that team. By having like a more holistic kind of team cognition, they try to bring all that together and put every single developer inside of the same level so that they all can be at the same pace, let's say. And again, team members align their knowledge and actions towards common goals. And in order for them to tear down the silos within the company, they think that that's why they want to try to reach or try to use monorepos. But with Amazon, the thing is it's completely different. So they tried, instead of using like a more holistic team cognition, they try to go towards a more collective team cognition, which is set of individuals have their own expertise, it's not shared, and there is less integration and shared understanding about this. So, any questions, any doubts so far? No? So that's the end of the presentation. Thank you very much. I hope this was interesting for you. So thank you.
I do have one question. Do you consider the Linux repository monorepo or?
It is not actually. I searched about this. So the Linux system, they don't use monorepos. They use a polyrepo approach. I'm not sure exactly why they do it.
I think it is one repository.
I'm not sure exactly, but I have this. I'm positive that I'm 100% sure that I found it to be a polyrepo, but I might be wrong. But let's say, for example, that
the reason that I asked is because, well, it lives under a single repository, but it's just one project.
Right. Okay.
So maybe it's not considered a...
Yeah, I mean, this is something that I didn't talk about because didn't serve my purpose. But basically, when you are dealing with monorepos, you can deal in two different ways. You can go for a more modular kind of approach, which was what I tried to show you here, which is you have different packages that behave like modules in which they can all work together inside of one repository. But if you need to, for example, put that into a single repository or hand over to it, you can do it quite easily. But then there is another approach, which is the more integrated kind of approach, where you don't have modules. Everything is interpreted as one single project, and yeah, so it's more difficult for you if you want to extrapolate that, put it into a single repository. You can't. It's more difficult to do. And maybe that's the example from Linux. Linux, they have a monorepo, but they use the integrated approach instead of using the more modular approach. Not sure if that answers your question.
Yeah. Thank you.
Thank you.
Any other questions?
Hi.
So monorepos obviously have a lot of benefits. But what you mentioned about it kind of spreads the ownership. Is there any tool, any process to set some boundaries and some ownership, but still use the benefit of monorepos?
Yeah. So in terms of ownership, I can try to give you my personal example. So. I use monorepos on the company that I work with, on the team that I work with, and of course, let's say that, for example, if you think about monstrous monorepos, that's a problem, because usually when you have that kind of repositories, it's not like one team working on it, and in that particular situation, I believe that you don't have any ownership. So you might try to have, for example, when I show you the feature, the modular boundary rules, that is a way to achieve that ownership, in the sense that you want to say that for a certain project or a certain module, that module cannot be imported in some way by other teams. That might give you a little bit of ownership. ownership. But on my particular case, I personally find more useful of using monorepos in a more project kind of environment, like small project kind of environment, because you can control all of the modules inside of it. And yeah, that's basically it. I'm not sure if that answers your question.
Thank you.
You're welcome.
Does anyone?
Hi.
Yes. Hi.
About permissions in a repo, for example, when you want specific teams or given developers to have specific access, take, for example, GitHub. In a monorepo, how would you be able to do it? By by giving a specific path, but I don't think it's possible.
I think it's more related to what are the intrinsic properties of a monorepo, because the intention of having a monorepo is for you to have this like workspace where you have all of your projects, but I'm not exactly sure how you do it, because fortunately or unfortunately, I'm not sure. I would say fortunately, I did not have to work with like in such an environment where you need to have so many teams working on the same repository. I was trying to give you my example before. So basically what I do is it's basically the example that I showed you in the beginning. So I work for a company that I'm developing 3 applications. The 3 applications have things in common, and because they have like this, what I told you in the beginning, this contextual relationship. So packages that have some connection with each other, I found it more useful to put that into a single project. And that's why, because it's only one team responsible for it, it's easier. But when it comes to more teams, maybe I'm not exactly sure how you do it via GitHub.
You probably could use the code owners and
yeah.
teams.
Yes.
Or like this folder belongs to this team.
Yeah, that might be a solution.
Yeah,
Yes.
but that doesn't stop any developers to just mess with the code. If you have an insider, for example.
Yeah,
on the security point of view, I mean.
Exactly. That might in that situation, probably what needs to be done is what I tried to show, which is try to invest in tooling. Try to find, for example, scripts or to create scripts on your let's say GitHub Actions, in which you can evaluate by the author that is making a commit, can try to identify if that user is from a certain team, and if it doesn't correspond, then it's not at all, you're not allowed to create a PR and merge that, for example.
So one solution create other problems. Or,
yeah.
Yeah. Or,
yeah. Always like that.
And I had also one question about CI/CD. For example, when I want to, if we split like microservices, like we spoke before, if you want to deploy, build Docker images, for example, OCI images, how would that work with monorepos? By adding more workflows?
No, that's the thing. Because you have this environment where you have all of those packages inside of the repository, you have the possibility to create a more generic kind of a workflow that works for all of the modules. So you can create, for example, that's what we try to do in my project. We try to create this workflow in which we can reuse or try to create all of the packages that we need for a certain purpose and put all of that together, or try to do that together in that workflow. So yeah, you don't need to worry about that. Should not be a problem once you have that approach. Not sure if that answers.
And you deploy, when you split into application A, B, C, you will have 3 different images, for example.
Right.
All right.
Yeah.
Hi, great talk, by the way.
Thank you very much.
Yeah. My question is, with the rise of AI and, this AI programming, AI agents, LLM, whatever you call them, do you think it's better to code in monorepo now because you have AI that understand everything in one place?
Yeah. Personally, thank you for asking me that question, because when I start thinking about a subject for this, a subject for the talk. And when I thought about monorepos, that was one of the first things that I thought about, AI. Because if you think about it, most of the problems that are right now attached with monorepos, like for example, if you think about the tools right now that exist to help you with monorepos, if you have AI agents that might help you identify potential, let's say, solve the dependency graph, for example, might give you like more like quick tools or quick handy hints for you to help you optimize your structure of the monorepo and therefore bring you more performance, for example. So I will say that yes, AI might bring you more advantages. And because of that, I believe that will help more the usage of monorepos rather than polyrepos, I believe. Not sure if that answers the question.
Yeah, it does, yeah.
Thank you.
Brilliant talk. Well done.
Thank you
For your first one.
Thank
Amazing.
you. Thank
Well
you
done.
very much.
Very thorough with all the information. This is a topic that I'm very passionate about because I use it on my daily job.
Nice.
And I just want to poke a little bit into the scalability issues on the monorepos. Yeah, because until that slide, I was thinking that your presentation was missing, and then it became complete for me, at least. I just want to share some thoughts because I've been there, and I don't agree with the 10 to 100 developers because it doesn't depend only on the developers, it depends on the amount of work that they're doing, especially with what you said on the trunk-based development.
Right.
You get into a deadlock really quick. Like you're rebasing, someone else creates some pull request, you're rebasing again, another pull request, and you're fighting against each other. And this can happen with 5 devs if you're doing really quick pull requests, as you should.
Exactly.
So I just wanted to put this out there because this has been my experience, and I don't know if you came across the same, but on this particular point, monorepos are dangerous.
Yeah, that's the problem. Personally, I didn't have that experience, but I can recognize that might happen. Yes, if you have that, let's say, competition, like having like all of those merges with the trunk. Not only you're also like spending too much resources to run the pipeline and run all the tests, and to run the test, that is something that's something that I have personally experienced. It's really hard for you to have everything like run at the same time, let's say. So yeah, I can relate with that.
Because you rebase, then CI kicks again, tests run, you constantly work. Anyway, it's cool to discuss these. Second, I promise I'm going to make a question.
Sure.
Have you experienced? Have you tried NPM workspaces instead of turbo thing?
No, actually, that's the when I start working with monorepos, the first thing was the first tool that I experienced was Turbo Repo. I've never used another one, but if I don't misunderstand, NPM workspaces is another way for you. It's like a more, I would say, more like simple solution, more basic solution, because it doesn't offer you the same level of tooling, same level of features that you might have with those kinds of tools.
Yeah.
So
I was hoping your answer would be yes, because then I would ask what were the advantages of turbo thingy, because I'm having a problem right now where my UI shared lib that we have in a package, we cannot publish it via like on NPM public registry and have it at the same time on the monorepo accessible without building. Whilst NPM, when you start workspaces, it allows you to consume files without building.
Right.
And Turbo Repo like builds automatically, like you said. So that's going to be the solution that I was trying to avoid going into. So hopefully you'd have some insight, but thank you.
Apologies.
No worries. Cheers.
Any more?
Well done.
Thank you. Thank you very much. So I don't think there's any more questions. So if not, thank you very much for the opportunity.
All right. Thank you very much. So the food is here, but we'll just have one more talk, which is Peter's one. So how MCP is changing the agents game. And I'm not sure if everyone is aware of what an MCP server is, but I think will leave today knowing what it is. So, Pedro? Yeah, you need to use both other. Yeah, one of them is for. Yeah, the other one is yeah.
Hold on then. This might take a little bit actually. Is this the other way? There you go. All right.
Maybe switching to mirrored mode.
I want to mirror. How do you do that? Do you guys know?
Display.
Mirror. There you go.
Yeah.
Amazing. All right. Not even full screen. Doesn't matter. Good enough. Hello guys, so how many of you have heard about MCP? Unfortunately, not Microsoft today. All right, so one person, I won't even ask, 2 person, 3 maybe? Okay, awesome. I was going to ask who has built an MCP server before, but I'm done with that for today. So yeah, my name is Pedro Figueiredo. I work as a software engineer at Neon, which is a Postgres serverless service kind of thing. And I work at the backend as a service team. Well, I was relegated to the AI team this week, so not on the backend as a service anymore. And I will be talking a little bit about AI, MCP servers, agents, and how does all that stuff relate with each other. This talk will be half theoretical and half will try to do 2 very quick live demos. Hopefully those won't go too bad. So as any sane person in 2025, the first thing I did when I knew I had to give this talk was to go over Claude, which is the same as ChatGPT for one who doesn't know. And I asked what's MCP in the context of AI. This was, I think, yesterday. As you can see, there is Claude Sonnet 3.7 that was released like 3 days ago or something. And I was very surprised when I got this answer. In the context of AI, MCP refers to something that doesn't even exist. So AI was hallucinating already. That was good. And there was a bit of fuck moment for me. But yeah, we got it. We got it. All good. So this is just to show how bleeding edge MCP is. Like LLMs that were released 3 days ago don't know about it yet. So don't worry that you have never heard of it before. Right, so I went over to Entropic's website, which is the folks that released the model context protocol. This is a protocol, by the way. And they have this really cool metaphor saying, think of MCP like a USB-C port for AI applications. Now, what does this mean? MCP, the model context protocol, is trying to create this standard for us to input data, basically to inject external data into AI. The same way that USB-C came along and tried to create this standard for us to input video, charger, computers, sound, like everything. And how does this relate? How does this all happen in a architectural wise? It's actually pretty simple. We just need a MCP client. That can be usually Claude. It's the most common one that supports it. Then we just have a server in the middle that we are going to build right after this. And it's actually pretty simple. And that server just acts as a proxy for you to get data. That can be like fetch my GitHub repositories, fetch the weather for Lisbon today, or anything else that you want. It can be what's in my local file system. It can be both local, remote, database, wherever you want. It's just a proxy. It's very, very simple, and you'll see how useful it is. Right, so what's the purpose of it? Why was it created? It was basically created to create a standard for us to provide context to LLMs and not have every goddamn AI person building their own abstraction that doesn't really work. And why did we actually need that way to provide context? It's because LLMs are great, they are very, very smart, but they are basically enjailed. They are within this cup, jar, whatever you want to call it, and they cannot access any other data besides what they know right now. So we need to open some holes in there and inject some external data. So if I ask an LLM what day is today, maybe they already know it, but if I ask them when is my birthday, I'm sure they will not know that, and I will need to provide that information if I want them to answer correctly. So how do you use it? It's very, very simple for them. Most times you just install a server locally. Nothing too complex there, doesn't matter. The next thing is we'll check in Claude if we have our tools available. Again, just checking, nothing too complex. In here, I was installing our Neon MCP server just for showcasing. And then I just asked Neon, can you, sorry, not Neon. I asked Claude, Anthropic, can you describe my Neon project? And suddenly, out of magic, it gave me all the details. You have like this project, you have this database, you have wherever. And without this MCP server in the middle, this was like impossible, of course. How would it know? And now, how does it relate to AI agents? So AI agents, there are a lot of definitions. People say AI agent for everything. But what's really an AI agent? For me, an AI agent is something that is an autonomous system and can act and resonate according to what's happening and doesn't need as much human interaction to do their own actions. So AI agents before MCP, they were like less effective. They couldn't do as much for sure. Every AI agent created out there behaved in a very inconsistent way. Maybe you have two AI agents capable of getting your GitHub repos. Maybe one will have it returning JSON, the other will have it returning as text, and the other, God knows what, will return. And yeah, basically it's all about lack of standardization. Now that we have MCP and it's getting a lot of traction, we have new things. We have a standard approach that then everyone can actually build upon. We have a growing community of MCP servers. So now people that build agents the most don't need to be worried about building, oh, I need an agent for GitHub, I need an agent for Reddit, I need an agent for news. Because people are actually building this in open source, so they can just take it for free, and they will be much better than the ones they were building. And it's kind of easy to build MCP clients, things similar to Claude that can use this. So here are some examples of products, agents, that are using MCP today. Claude was the first one, and then very recently we had Cursor adopting it, Windsurf, those are two code editors, and the other one is called Clyde, not so well known. Small summary, yeah, MCP is a standard for injecting external context into LLMs. Agents can do way more than just responding to the stuff they were taught with or they were fine-tuned with when they are released. And MCP really is just getting started. So after this presentation, try to build your own MCP server. You'll see how great and how easy it is. We'll pass on this and we will go with the actual thing that matters. All right, so here we go. let me open this and let me zoom a lot. All right, guys, so we are starting with an empty canvas, which is always a good sign. And I did this demo today for the first time on my way here in the bus, and it worked one time. So I'm expecting it to work at least another one. So yeah, I'm just going over to the docs really quickly. And I know that I have to install some dependencies, so I'm just going to do that really quickly. So yeah, I'm using bun, and we really just need these two dependencies, and that's good to go. And now, yeah, that doesn't matter, and we are going to build your server. So we are going to copy paste this stuff in, and I'm going to talk about what matters then. And this stuff doesn't matter. So we are going to delete it, and what this matters. So we need to create a server instance, and we'll give it a name. Today we'll be creating a Dead Jokes server. So let's call it Dead Jokes. Oh yeah. Who in here has never used Cursor before? Okay, so yeah, guys, please do yourself a favor and try it at least. All right, so we have created our server, and this guy is already giving me stuff. Yeah. Let's go over here again, and now we just need, I'm going all the way to the bottom because this stuff doesn't matter. I'm just going to do the running server part. All right, so we have the server instantiated, very easy as you guys are seeing, and then we are just starting the server. Nothing to talk about here. Let's go to the cool part because we haven't done nothing yet. So the cool part is actually defining tools, and these tools are the magic sauce of MCP servers. Tools, as you are already seeing there on my cursor autocomplete, is what will give us the external context and inject it into the LLM. So I will try to do this without much help from. Yeah, so we are just going to say that we want a new tool. And now we'll just say what's the tool name, and I will say maybe get. This is hard with just one hand, but I'll try it. Get joke. And for most cases, the description doesn't really matter, but for AI, this is one of the most important things ever. Because if you don't give it a good description, the AI won't know when to use this tool. So it's fairly important that we give a good description. Actually, get a random joke is a good enough description. So let's write that down. And now the most magic sauce part, which is we actually need to fetch a random joke, and yeah, let's return it. Yeah, that seems good, and that seems good. All right, just to, oh yeah, so we have built a tool called getJoke. The description is get a random joke. We are fetching a random joke from somewhere. And let me just see if this is right, but I think this is right, yes. We get the response, and we are sending it back. So I think everyone can understand what's going on here. So how do we actually try this stuff? We need to build it, and let me do npm run build. All right, let's see if we have a nice, oh yeah, we got it. And now what we need to do is we go over a Claude file and we register Elia. So we'll call it deadjokes. This is just a server name, could be anything really. I'm going to put this here. I'm going to copy this executable path, copy path. And I'm just going to lay it here, slash index.js. Okay. All right. All right. So that seems kind of good. Let's try it. How do we try it? I'm just going to open Claude. All right. So Let's look at our tools here. And I don't even know where that is, but there we go. Get joke. Get a random joke from servers that jokes. Let's try it. Tell me a random joke. That joke, right? Yeah, we need to allow it for at least for the first time. I'll just do it allow once. And Bad at Golf joined the club. Awesome. Everyone laughed. As you can see, it did invoke a tool called getJokes from the server thatjokes. Just call it again. Another, please. Yeah, allow for this chat. And there you go. What's the difference between roast beef and pea soup? Anyone can roast beef, but nobody can pea soup. Okay. It's looking great. So yeah, as you can see here, this is just how the LLM decided to call it. It decided to call it without any params because we didn't say it needed any. And that's basically the response it got off our handler, our tool that we just wrote. Awesome. So that's part one of our demo. Nothing too surprising here. It was really just clicking tab all the way through, as you saw. Let's try to do something a little more surprising. All right. So let me zoom it. Okay, so this is the website I was getting the jokes from, but I was getting them from an API, right? What I'm going to do now will be completely different. I will go over to Cursor. Okay, awesome. And I will use the best model and Composer. Click here. For the ones that don't know anything about Cursor, well, deal with it. We are going to use the agent mode. For the ones that don't know, agent mode will actually provide code, and if there are any errors, it will act upon the errors instead of just writing them. So as I said before, an agent is something a little more autonomous. And in here, we'll say, please scrape scrape this, get 20 jokes and insert them into my project. And now I think I need to feed it with a... sorry guys, there was something that I forgot about, which is I kind of need to give it. Actually, I will do it a bit different. I will go over here and ask for list my Neon projects. Neon, as I said, is just a cloud database kind of thing. So I will just get my databases or my projects, and there we go. This is what I wanted. I created this project just for today. And I will give it the name, and let's go over to Cursor again, and yeah. So basically I'm asking them to scrape HTML, get this jokes data, and insert them into my project. So let's try that. I'm not sure if it will be able to do it all at once, but let's see. So Cursor also has access to MCP tools, like MCP servers, like I told you before. And it's checking a lot of stuff, apparently. It's reading files. It's now, yeah, there you go. So first tool call, and it's scraping. This is another MCP server I have installed just to scrape HTML. And there you go, it did something. Now, it takes sometimes. Oh, there you go, it's already moving in. I need to get more jokes. Okay, sure, go ahead. yeah, so it's doing stuff that I don't want it to, but it's fine. Hopefully. Yeah, for some reason it stored them in there.
Just a quick question.
Yeah. Go ahead.
Also have access to the Neon MCP server?
I have those two installed. I have one for scraping and another for Neon. So this time I only have two installed. And it did a lot of stuff that I don't want it to, so I'm just going to stop over here. Because as you saw, it scrapes, but it was not going in the direction that I wanted. So I'm just going to copy this stuff. Right, at least it got the 20 jokes out of the scraping, which is like good enough. So what I'm going to tell now is actually we create tables, jokes table in my project. Hopefully it still can remember it. This there. Right. So hopefully it will understand that it will need to go over. All right. So it's going to like list my Neon projects, and then it will get that information. Great. You now have, yeah, sure. And now it will describe the project just to figure out that I don't have a jokes table there yet and there are no conflicts. And now it's going to run some SQL. And now hopefully this run SQL will be to create the table. Sure, let's create a table. And now it's going to prepare a database migration. Sure, that seems good to me. And this is the trick with AI. You just accept everything it says and you don't really read about it. And now it's calling run SQL again. You just go with it. Check if the table is there. That seems good also. Great. It was created. Complete database migration. Awesome. So there you go. Now let's insert the jokes into the table. So is it doing that? Is it not doing that? Yeah, there you go. Run SQL transaction. Awesome. So all of these that you are seeing here are tools that are created in the Neon MCP server, by the way. Awesome. To include the function to get the table from the database. No, I don't want that. Okay, awesome. It did a lot of stuff. Let's just check if it's there, actually. Okay, I have 20 jokes here in my Neon database. It just has an ID, a joke test, and a created at. Now let's go over to our HTTP server that I created previously, and let's tell it yeah. Too big. All right. Get, actually select all the jokes according to my project, to my DB schema. Okay, so the guy is, or the girl, I don't know. It's not cooperating, so we are just going to do it by hand. So we are doing that, and I think, if I remember correctly, it's called joke text. From jokes order by ID. And we are going to return the jokes over here. That part seems good. And now the only thing that's missing is in the indexed HTML, we have something to render those jokes. And I think we need to adapt it somewhere. Yeah, so in here it was joke.question. We don't have that anymore. We only have joke.joke. What did we call it? Joke test. Okay. So I think I'll just put everything in here. I don't even know. Hell yeah. Okay, let's open this. Copy path. And it didn't render. Okay, it doesn't matter. That was not the point. It should have rendered something. Let's just check if the server is running. I might have forgot about that. All right, so there are no jokes after all. So it was not a lie. What did we do wrong? So let's check that. Select, sorry? Jokes. I think it is right. Let's see if it's the connection string that we provided. Copy. Oops. This is the last try, I promise. Okay, let's try it. I'm going to reset that. I think I know what's going on. I forgot to reset the server. God damn. Okay. Oh, yeah, that's beautiful. There you go. Amazing. Round of applause for AI. Yeah, guys, that's all I had for today. I think I had a slide saying Q&A, but that doesn't matter as much. If you have any questions for me, anything about AI or other, I'm happy to take them.
Hi, just regarding like the beginning of the talk where you're talking about the purpose of MCP was, kind of a standardized protocol providing context to the agents. What about because we have protocols in the industry that are like OpenAPI or even the base HTTP protocols. All of their purposes was to do the same job, like pass the context to standardize the context. So yeah. So what's the difference between me using OpenAPI versus MCP?
Yep, that's absolutely a great question that people that are very well known in the AI realm are still trying to figure out, which isn't OpenAI enough? That's like the big question. OpenAPI, I mean. And the answer is OpenAPI that people are giving is that OpenAPI is one, too complex, and too related to HTTP to be able to serve agents well. And what I mean is, as I said, the description here needs to be very turned towards AI. It needs to, like the same description that you will have in your HTTP endpoints will not serve wherever AI needs. Also, OpenAPI has a lot of stuff that AI cannot have due to, security concerns or whatever, and we would need to do a subset of that just to use it within AI. So I guess that's like the answer. It could be used with that. AI would probably be able to take it and use the same way. People are saying it's way too complex for what we want right now.
Okay, so my understanding is that, so the purpose of OpenAPI is talking with resources, of the internet, of HTTP. So you have the protocols like get, put, post, but the agent does much more actions than that. So we need more actions available rather than just get or post resources. Is that correct?
Yeah, I guess that's one part of it for sure. And I guess right now the MCP protocol is very, very, very small. And that's great for AI because AI, it's already bad in hallucinating with things. So the more things we put in the language, whatever you want to call it, the less, like, the more shit the bad it will do. And so if we keep this DSL as small as it is right now, we can train AI, we can fine tune it, and it will be fairly good in doing what we want it to do.
Okay, yeah, just one last question. Yeah,
for sure.
Yeah, can you give me like an example of what, like, compared OpenAPI versus MCP, like what MCP can do now that OpenAPI can't do? Like what isn't compatible with well designed for the agent? Like what specific?
No, I think it's it's the other way around. It's like I think OpenAPI can probably do everything that that MCP can, at least just the inner protocol thing. But it can do so much more that AI is not ready to receive and interpret. That's the thing. Like the guys that created this protocol, I was in an Entropic talk last week, and they basically were telling that they really wanted to start small with a very concise protocol that only allowed very, very specific properties, and then they wanted to evolve in time with AI alongside it.
Yeah, interesting. Thank you.
Thank you for the cursor ad and the Claude ad, and yeah, I think Anthropic did do a really good job at like making everything open, and yeah, I think congrats to them as well for keeping that. But yeah, I found it very interesting, like the capabilities of the MCP server, and I guess congrats as well for the Neon MCP server, because I think you really showed the capabilities of it here. My question is, when do you think companies should create their own MCP server? Because I think that, yeah, in the case of Neon, it does really benefit because it increases people using Neon. But yeah, what are other use cases where you see MCP servers being good for the companies that...
Yeah, for sure. Like one very easy thing to say is any company that has a managed service should absolutely build one MCP server. Like it's so easy, and it's not that people are going to use it. People are probably not going to use it. It's just that you put yourself and your company into the AI space very, very quickly. Like just to say, Neon, we built this MCP server like 1 week after MCP was released, and we had so many people talking to us thinking that we were this AI genius guys. We were not AI genius at all. And then, yeah, opportunities started to open. We literally made clients contracts because of showing off our MCP server. It was amazing. And it's really getting started. So like managed services, like create projects, create databases, any cloud service that you have, try it. Other things, it's just tools that your company might have. Let's say scrape data, let's say, I don't know, like, yeah, anything that you can think of. And I didn't say it, but all of this is local, so there aren't as many security breaches because you are just running your server locally. Yeah,
thank you. I really see it like, for example, Excel might be a really good.
Yeah, there is one very cool that I wanted to show today, but I couldn't, which is browser tools. And what it does, it connects to your browser tab that it's currently open, and it reads from your console, it reads the logs, it reads the DOM, it reads everything. Like you have your mouse on top of an element, and you just go to cursor and you say, I want this element to be round and not square, and it, boom, that happens. So it really is amazing, and a lot of cool stuff will start to pop up every now and there.
All right, thank you, and thank you for the interesting talk.
Thank you, guys.
Any other questions? No? Okay, thank you. All right, then without further ado, thank you all for attending. Thank you, Riskified, for sponsoring this event. And please enjoy the food that's out there, because it's thanks to Riskified. So thank you again.